Thanks for coming back to Jacobit's Learning Group. Let's go into inequalities. Um, so when we look at this equation, so sketch the graph of each linear equality, guess what? We only have one. So it's just this one. It says step here, first step is you're going to look at this is solve for the equation, pretend that the inequality sign is an equal sign. So y is greater than or equal to negative 3x plus 4. So this is what we have here. You have a greater than or equal to. So if x equals 4/3, which would be what, 3 into 4, 3 into 1 is 3, minus 1, so it'd be 1 and 1/3 is really what x is equal to. But anyway, as we are solving for the equation, we're going to go ahead and find some answers here, and you will then get the equation that x equals 4/3. So we keep that in mind. You keep your equal sign here so that when you're solving, it's no big deal. And here it says when you want to find the value of the x-intercept, it's when y equals 0. This is something that gets confusing because even sometimes teaching this, it gets confusing for me. Because you automatically want to think that your x-intercept should be x-intercept. Y-intercept should be y-intercept. X-intercept is when y equals 0. Because I know when I was in high school, I thought x-intercept is when x equals 0, but it's not. So you got to be careful there. So you automatically go over here and make your y the 0 point. And then you solve and you end up with this x equals 4/3. Okay, so when you put these equations in and you have, actually this is the other way around, x is 4/3. Here, this should really be 4/3 and a 0. So it's when your point is here, 1 and 1/3, x is 0, your point is here on this line. So you kind of have a graph going here, so you should know now everything is going out. Now you want to decide when x equals 0. So when x equals 0, you're going to get that y is equal to 4. So 0, and here this was done for you, that's 4. And then we can move on and find our line. Now, why are you solving for when x equals 1? Because you want to see if your line is consistent. And if it's consistent, you can get into axis of symmetry, you can get into other things as long as you can see that it's equal to that. So if you put 1 here and solve, you get negative 3 plus 4, and you get y equals 1. So you have both x and y are 1. So does that satisfy the equation? Yes. So your one value is okay, so you know your line has to go somewhere over towards this way, and maybe these points don't, so your graph would be here. When you go back and you put the inequality sign in here, you got to go back and check your other regions. And when x equals y is the equation 2, is it 0? Is y equal to 0 here? Is x equal to 0 here? So when you go back and do that, that's not what happens. Your 0 point here is not going to give you this here. It's going to give you that y is equal to 4 and positive 4. So which are points we already did. So guess what? When you look over here and you say no, those points can't be on the line. So your inequality starts with 1, 1, and most teachers will tell you to go over here so that you know that it's going somewhere past this line, and it's all these points that are here from this 1, 1. Why aren't you going here? Because this would be 2, 0, and that's about the last thing. Anything else over here is 2, negative 1. And this graph kind of only stays true when you think about it. If you put y is greater than or equal to negative 3 times, let's see, positive 2 plus 4, you're going to get negative 6 plus 4 is going to be negative 2, y is going to be negative 2 over here. Well, negative 2 is over here, so it's not on your graph. And this equation then is not going to be true, because that's going to be your answer. So you want to make sure all your points would lie over here, and that's why your shading is done this way. We'll do another one in the next week or so, just to make sure that people are watching this and they're staying abreast of it. Thanks so much for watching this video.